All right, for this problem here, we are dividing the square root of 24x by the square root of 60x squared. So let's start off by using that quotient rule that tells me that the quotient of these radicals is the same thing as the radical of the quotient. So I can rewrite this problem like this, and now let's go to town, simplifying what we have on the inside. 24 and 60 each have a common factor of 12. So if I take a 12 out of 24, I get 2. And if I take a 12 out of 60, I get 5. And then also with the x's, I get some canceling here. There's 1 on top and 2 of them on bottom. So this goes away completely. It becomes a 1. And on bottom, I have an x to the first power. So that was just a whole bunch of writing over stuff. So let's simplify this all out, or write out cleanly what we have. Got the square root of 2 over 5x. And at this point, I'm ready to split out my radicals again. So the square root of 2 over the square root of 5x. Now I got that pesky irrational denominator again. So I want to rationalize this denominator, and the way that I'll do that is by multiplying it, top and bottom, by that radical in my denominator. So the square root of 5x over the square root of 5x. Remember, this is legal because whatever this number is, it's equal to 1, since anything divided by itself is equal to 1. So this is going to give us, on the top here, I'm going to have the square root of 10x. That's multiplying the square root of 2 times the square root of 5x divided by 5x. Now, if you're having some trouble seeing where this square root of 5x times this square root of 5x brings me back to 5x, well, think about what this means. If I were to multiply these two things together and keep it under the radical, I would have 25x squared inside my radical here. And we can see here 25 is a perfect square. It's 5. And x squared is a perfect square. Well, that brings me, the square root of x squared is x. So I can eliminate this radical if I multiply it by itself, really. So hopefully that helps. And this is my answer to number 12.